Hello, Mr. Betts here. Let's take a look at an example where we have solar panel production decreasing year over year. The idea here is a brand new solar panel is going to be producing more, and then as it ages, it's going to produce less and less. And that the amount of production is pretty closely modeled by an exponential decay problem. So the problem here says that after 25 years, we're expecting 80% of its original output. And we know that it's expected to decrease at a rate that's proportional to its output. So that means that we're looking at this differential equation right here. Okay, so this part right here, decrease at a rate proportional to its output, gives us this differential equation with a solution of. And by the way, on all these examples, I'm using y as a variable, but we could have, let's say, p for production if we wanted to. We could use different variables. We just have to know what that variable means in the context of the problem. So we want to solve for, eventually, we want to know what is the production going to be after the first year. But to find that, we're going to need to solve for k, and we can use this condition right here, this data point, 80% of its original output after 25 years. So 85% of its original output, I'm going to just say 0.85, I'm sorry, 0.80 equals 1 times e to the k times 25. So pretty simple equation. This equation is indicating that the solar panel is producing 80% after 25 years. And to solve for k, we take the natural log of both sides. And we're going to divide by 25. And that's going to give us our k value for this equation. Then what I want to do is figure out what is the output going to be, or the production going to be, after 1 year. So I'm plugging now 1 in for t, and we're going to get the production after 1 year, or the output after 1 year is going to be the initial production, which is 1, times e to the k, which is natural log of 0.8 over 25 times t. So t is going to be 1 because we're looking at each year. So I'm just going to look at what it is after the first year. And so we're going to plug this into our equation or into our calculator to see what the production is after the first year. Now that's going to give me the percent of the original output. So it's going to be a percentage like 99%-ish. And then I want to know how much it decreases each year. So I'm going to take 1 minus that and convert that to a percentage. So plugging that into my calculator, the production after 1 year is going to be a little over 99%, 99.11%. And then converting that to a reduction, we're going to have, looking at this right here, it's going to be, I'm going to write this out as a sentence. So production output will decrease. Now I said decrease, so I'm not going to include the negative in my answer, by 0.889% each year. So that means that we can expect about a 1% decrease in production each year from the solar panel.